Yes, sir. Yes, sir.
Ruben, talk to me.
Sir, please, you study physics.
Yes. Oh, we can't do maths rest on a row. So that tomorrow we do commerce.
Okay, sir.
You get it?
Yes, sir.
Good, good. So we are doing light energy today. I hope you all have an idea of light energy. What light energy is. I think energy in the first place we see is the ability to do work or something. Yes, that's what we define energy. And if you study energy into details, or maybe your normal energy background you have, or literature you have, you know that we have various forms of energy. You know, we have the solar energy, that is energy gotten from the sun. You know, we have electrical energy, that is energy gotten from electricity. You know, we have chemical energy, that's normally gotten from compounds and so on and so forth. We know all these types of energies or forms of energies. And we know we have light energy, and that is what we are going to talk about today. And under light energy, we are going to talk about a whole lot of things about light energy. We are going to consider the properties of light energy. From there, we take the properties of light energy and we delve much deeper. We discuss the properties of light energy. We are going to talk about the sources of these light energies. We are also going to talk about we are going to talk about a whole lot of things. From there, we are going to talk about reflection. I'm going to talk about refraction. I'm going to talk about the eye. I'm going to talk about colors. Even dropped in your sister's question that I gave it to you the other time. I'm going to talk about all these things. So you humbly take note. One may ask, what is light energy? We are all learning. So what is light energy? Who can just tell me a little bit about light energy? Ruben, talk to me.
Light is a form of energy that enables us to see.
Good. So light energy is a form of energy, or is a type of energy that enables us to see, or that makes vision possible. And so without energy, light energy, vision won't be possible. That is why when it is light out, it is very difficult for you to see in the dark. You would have to resort to what do you call it, uh, torchlight and so on and so forth. So light energy is that which makes vision very possible. And so we can see that scientifically, we can also say that light energy is a form of energy and an electromagnetic radiation which travels in a straight line with a speed or at a speed of 3 by 10 raised to the power 8 meter per second in vacuum. So scientifically, we can also define it that in that way. Light energy, number one, is a form of energy. That's number one point, right? And it's an electromagnetic radiation. It's an electromagnetic radiation. It falls under the visible light. When you study the electromagnetic radiation spectrum, it falls under, you know, under the spectrum, we have the radio waves, we have the gamma rays, and the rest. The light energy forms under the visible rays. So it's an electromagnetic radiation, and it travels in a straight line. Already we know this. Like light energy travels in a straight line with a velocity. The velocity is the speed of the light of 3 by 10 times 10 to the power 8 meter per second in vacuum, in other words, in space. Now, light performs two main functions. Function number one, that it makes vision possible, or it promotes vision. So without light energy, you can't be able to see. You can't be able to see. So light energy makes vision possible. And in humans, what we used to see, what we use to see is our eye. That is why under light energy, we are going to talk a little bit about the eye. Now, number two, light energy is used in the preparation of food. So you bear with me that the plants need light energy to photosynthesize or for photosynthesis. And so as a result, the byproduct, we can benefit from it. I hope you get it. Now, light energy falls under or is part of a group of waves called the electromagnetic waves that I've already explained. And it has the following properties. So I'm going to talk about the properties of light energy. Light energy, number one property, we know that light energy travels in a straight line, right? That's we call the rectilinear propagation of light. I'm going to explain all these things. Light energy travels in a straight line. In a straight line. Then we say light energy has a speed of what? Or travels with a speed of? Someone should tell me. It travels with a speed of
3.0 times 10 raised to the power 8.
3 times 10 to the power 8. We can also say that light energy can be reflected. Light energy can be reflected. We will discuss all these properties as time permits. That light can be reflected. Light energy can be refracted. So light energy can be refracted. Light energy can be deflected. When I say deflection, I'm talking about the passing of light energy through an opening, a small opening on an aperture, or the spreading of light energy when it passes through an aperture. Or the spreading of light energy when it passes through an aperture or a small opening is what we call diffraction. So light energy can be diffracted. Now, light energy can be interfered. So we can talk about interference. Interference, yes. Interference. So light energy can be interfered. That's the crossing of light energy. We can also talk about that today. We can also talk about that. So these are some properties of light energy. We are going to delve much deeper as the class proceeds. So we know that light energy travels in a straight line. That's when we get to a topic we call rectilinear propagation of light. The property or the phenomenon that states that light travels in a straight line. We are going to talk about that. We are going to discuss an experiment to ascertain the fact that light energy travels in a straight line. We are going to talk about that. Number two, we are seeing that light energy travels with a speed of 3 by 10 raised to the power 8 meter per second. Now, what this statement means is that light energy, you realize that the unit is meter per second. That means light energy travels in 3 by 10 raised to the power 8, which we can see that I think 300 million in just a second. So light energy is able to travel a distance of 300 million in just a second. I hope you get my point. So for instance, when you go to the examination, when you're asked to explain the point that or explain the statement that light travels with the speed of or travels at a speed of 3 by 10 raised to the power 8 meter per second, this is what you say. The 3 by 10 8 meters means the distance, and the second means in 1 second. So that means in just a second, light energy is able to travel a distance of 3 by 10 raised to the power 8, which we can also say 300 million. This shows how fast light energy is and the length at which light energy can travel. That means in 2 seconds it can travel twice of it, which is 600 million. I hope I've made myself clear.
Yes, sir.
Yes. Now we are saying that light energy can be reflected. So here we are going to talk about a principle called reflection of light. And that's you already know, the bouncing of light when it hits a smooth surface. I'm going to talk about all these when we get there. We can also talk about the refraction of light, the bending away of light energy when it moves from one medium to another medium of different densities. We are also going to talk about that. We are going to talk about refractive index and all these topics. And from there, we can talk about diffraction, just I've already explained. The spreading out of light when it passes through an aperture or a small hole or a small opening. And so we can also talk about that. Then we can talk about interference. That means meeting of light waves has to do with the interference. So we can talk about all these things. Now, having at least been briefed about the properties of light energy, we can also talk about the source of light energy. The sources of light energy. Now let me use this thing. I hope you are writing.
Yes, sir.
We can talk about sources of light.
Sir.
We can talk about sources of light energy. Of light energy. Of light energy. Now, the first sources of light energy we are going to talk about. We are going to talk about two main sources of light energy. We are going to talk about the artificial source of light energy, and we're also going to talk about the natural. Now, the artificial, when we say anything artificial, we are talking about any light energy source that is made by man. I hope I made myself clear. Now, when we talk about the natural, we are talking about those made by God. Example, the sun, firefly, glowworm, and all those things. The moon, they're all made by God. So these are natural sources of light energy. And the latter, the other one I said, the previous I said, the former, sorry, is that of artificial. Example is the torchlight, the bulbs, and so on and so forth. The filament bulbs, and so on and so forth. These are artificial sources. Now, these sources can further be grouped into two main bodies. Now we are going to talk about it can be grouped into luminous bodies, and it can also be grouped into non-luminous bodies. And so the artificial, both the artificial source, and natural can further be grouped into luminous. Number one, can be grouped into luminous bodies. No, luminous bodies can also be grouped into non-luminous bodies. Non-luminous bodies. Now, one may ask, what are luminous bodies? When we say bodies are luminous bodies, or which groups of, or which types or sources of light energy can be grouped under luminous bodies, and which of them can be also grouped under non-luminous bodies? Now, when we say luminous bodies, we are just trying to say that these are bodies or these are sources of light that gives off light, that produces light on their own. Let me put it that way. Or these are bodies that give off their own light. So they give off their own light. That means they produce light on their own. They don't have to depend on someone before they can be able to give light. So they give light of their own, or they give light, they produce light on their own. Let me put it that way. Now, examples of these luminous bodies we'll have to talk about. Some can be natural, some can be artificial, just as I've already said. Now, examples of these light luminous bodies include the sun. So we can say that this one gives light, gives off their own light, right? Their own light. Now, example, we can say, example, give me some examples of this thing that gives off light on their own. Ruben, talk to me.
Sir, please, I want to ask, if they ask a question about sources of light, how do you know that they are expecting the natural and artificial, or the luminous bodies?
A question should be able to tell. A question should be able to tell.
Okay, sir.
Yes.
There's luminous bodies. Can glowworm be part?
Then,
Can glowworm be part of the?
yes. So glowworm is an example. Glowworm is an example. PSA, give me one.
Firefly.
Example of luminous bodies. Bodies that give light.
Firefly.
Firefly. Firefly. Ruben, give me another one.
Fire.
Okay, fire. That's firewood or fire. Yeah. PSA, give me one.
So the sun.
The sun. Ruben, give me one.
Said, please, that's what I know.
So torchlight. Torchlight is also part. It produces its own light. Torchlight, they are all parts. Rechargeable lamps and so on and so forth. They are all parts. Now let's talk about non-luminous bodies. We can say they are vice versa of luminous bodies. These are bodies that do not produce or that does not give light on their own, but rather reflect light from luminous bodies. So they normally depend on luminous bodies. They reflect light from luminous bodies. Example. The example is the moon. Give me some the moon. I've said the moon. Ruben, tell me one. We can talk about glass, mirror, and so on and so forth. Those objects that can reflect light. Are you getting it?
Yes, sir.
Water, and all this thing. They all can reflect some light. So normally they benefit from the refraction and so on, and the refraction, reflection, and so on and so forth. So we can talk about all these bodies. That is it. Now, after all these things, we can further group them. Now, the ones I'm talking about, they are not this thing. They are all this thing, but based on their properties, based on the properties of these materials, we can group them into three, based on the way they act, the way they behave. These bodies, these examples I'm talking about, not the bodies itself, but the examples are not the bodies. We can further group these examples or these materials that reflect light into three main groups. We can group them into translucent bodies. We can group them into opaque bodies. We can group them into transparent bodies based on their nature and how they react to what do you call it, provision of light, or allowing light to pass through them. Let me put it that way. Now, bodies can be grouped into translucent bodies. We can have them under opaque, and can also have them under transparent bodies. We can also consider them being incandescent or and fluorescent bodies. We can also consider them being fluorescent bodies. So I've said a lot. We are going to delve much deeper here. So we are saying that bodies can be grouped into translucent. This you already know, translucent. Who can tell me, give me an example of translucent? Who can, now when we say translucent bodies, these are bodies that allow small percentage of light to pass through. They allow small percentage of light to pass through, pass through them and reflect the rest. So they just allow a minimal percentage of light to pass through them and reflect the rest. So can you give me an example? Can you give me an example? PSA, give me an example of translucent bodies.
So I don't have an idea.
You said you don't have an idea. So you can talk about bodies that cannot be seen clearly. So we can talk about bodies that cannot be seen clearly. So we can talk about a tinted glass, or in other words, frosted glass. You realize that some of the cars, they have that tinted glass. You cannot see through clearly. You can just see some glimpses of people in it, but you cannot see through them clearly. I hope you've seen those glasses. Or you've not seen glasses, those glasses.
You see,
So we can talk about frosted glass. We can talk about oiled paper. When papers are oiled, light is able to pass through them small but not full. So these are examples of translucent glasses. I even use one here. I even use one at home. So when someone is behind my glass, the person cannot see me unless maybe it's night and my lights are on. But when I'm inside, I can see outside. There's an example of this thing. So we can talk about examples. We can talk about frosted glass, frosted or tinted glass, frosted glass. We can talk about oiled paper and so on and so forth. Now from here, we may have to also consider one body. We can also consider opaque bodies. Opaque bodies. Now, opaque bodies are bodies that do not allow any amount of energy, any amount of light energy to pass through. They do not allow any. So they do not allow light to pass through them. Who can give me an example of it? Human beings, you have one. Human beings. Ruben, give me one.
Wood.
You said wood. PSA, give me one. Give me one. PSA, I'm waiting for you. PSA. Can't you hear me? So we can talk about Ruben, but you can hear me, right? Ruben.
Yes, sir.
So we can talk about wood. We can talk about a whole lot of things. Things that are opaque, that do not allow light to pass through. There are plenty. Human beings, wood, plastics, and so on and so some plastics and so on and so forth. So that is it. Now from there we can also talk about transparent materials. Transparent. These are materials or these are bodies through which light passes through. That either allows or does not allow light to pass through, but they work with light energy. So these are materials we are going to talk about. So we have the translucent materials, we have the opaque bodies or materials, we have the transparent. Now when we say transparent, they are bodies. Transparent are bodies. They are bodies that allow a large amount of light to pass through them. So they allow a large amount of light to pass through them. So they allow a large amount of light to pass through them. But with the opaque, they do not allow any amount of light to pass through. They rather absorb the light energy. They rather absorb it. They do not allow the light to pass through. They rather absorb. But the translucent, it allows a minute amount of light energy to pass through and reflect the rest. And the transparent, it allows a large amount of light energy to pass through them. Pass through. Now, can you give me an example of transparent this thing? Can you give me an example of transparent? Ruben, give me an example of transparent materials.
White dress.
Are you sure white dress is that transparent? That when you look through white dress, you can see someone in it. Are you sure? White dress can be a form of what do you call it? A translucent. But plain glass. So you agree?
Yes, sir.
Plain glass, water, plain glass, even water. When you look through water, can't you see anything that is in it?
So you can.
Example, yes. So these are all examples of transparent bodies that you can take note of. Now, from here we are saying that we can also group the bodies into what we call transparent, what do you call it, incandescent bodies, and they are grouped based on their nature, the way they behave, and so on and so forth. That's why we have a lot of body categories we are grouping them into. We can also group them into incandescent and fluorescent bodies. Now, when we say bodies are incandescent, these are bodies that produces light when they are hot. So these are bodies that produces light when they are hot. Incandescent. Incandescent. So these are examinable questions, especially under light. Incandescent. So they can just ask you to define the following bodies: incandescent bodies, transparent bodies, fluorescent bodies, phosphorescent bodies, luminous bodies. They can tell you all this, and then you just define all. They can give you one for each or two for each. I hope I made myself clear. This sources produces light. Let's produce light. When hot. So these are bodies that produce light when they are hot. Example, can you give me an example? Firewood. 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 Who can you give me an example? Bob. Tungsten bulbs and the rest. Tungsten bulb. We can also talk about the sun. The sun also produces light when hot. I hope you bear with me. Oh.
Yes, sir.
We can also talk about filament lamps and the rest. The bobo and the rest you've been using, they all produce light when they are hot. Now we can also talk about fluorescent bodies. Fluorescent bodies. They produce light when relatively at a relatively low temperature. They produce light when they are not hot. You can put it that way. So they produce light without necessarily being hot. Example, example is a glowworm. A glowworm. They produce light without necessarily being listen. Glowworm. You have firefly, and so on and so forth. Fluorescent tubes, deep sea fish, and the rest. So we can talk about fluorescent tubes. We have about 10 minutes to end the class. Fluorescent tubes. And we have deep sea fishes. So that is it. Now we can also talk about one last one. We call it phosphorescent bodies. Phosphorescent. Now these lights or these bodies, they absorb. These bodies absorb the incident light energy and react chemically to produce light. So they absorb the incident light energy. They absorb the incident light energy and react chemically to produce light. They absorb the incident light energy and react chemically to produce light. In other words, you can also say that these are bodies that produces light at a relatively lower frequency. So they produce light at a relatively lower frequency.
Yes.
Now, let me give you an example. You bear with me that when you're in a room, when a room painted white, and there's light out, you realize that you can be able to see a little because of the paint, the white paint. Have you noticed that? Hello, oh, I'm talking to you guys. So. PSA,
Yes, sir.
can you relate to what I'm
Sir.
saying? Yes, talk to me.
Yes, sir.
So you realize that when you're in your room, normally when the room is painted white, my room is painted cream. But normally when it's light out, at least because of the color, you can be able to see a little because of the color. The color gives off a little light. Have you noticed that? Even your dress, the clothes you are wearing, when it is white and it is light out in your room, you can easily identify the person wearing white because of the color. But if the person is wearing a different color apart from white, especially maybe black or blue, it is very deep blue. It is very difficult to what do you call it to see the person. So these are bodies that gives light at a relatively lower frequency. Example, when you are walking in the night and you see a signboard, normally the signboards that are white or that are yellow or green, very light green, it is very easy to locate that there's a signboard in front of you than the signboard that is maybe blue or maybe blue or brown or something. Have you noticed that?
Yes.
So these are bodies that give light at a relatively low
Yes, sir.
frequency. Example is paint, paint. So some paint gives light at a relatively lower frequency, and our colors, they give light at a relatively low frequency. At a relatively low frequency. A relatively low frequency. So that is it. Now from here we are going to take the properties and discuss them one by one. Now, the first thing, can I clean the board? Can I clean it?
Yes, sir.
Okay. Now let's talk about some. I told you we are going to discuss the properties written above one by one. Now, the first property we are going to talk about is rectilinear propagation of light. Rectilinear rectilinear propagation of light. Can you tell me a little bit about rectilinear propagation of light?
So
Yes.
It is a property of light that shows that light travels in a straight line.
Great. PSA, talk to me.
Sir, please, it shows that light travels in a straight line.
Okay, so rectilinear propagation of light is the idea that light travels in a straight line. So the idea that light travels in a straight line is what we term as rectilinear propagation of light. And even the headline or the topic defines it or explain it well. Rectilinear means linear or straight line. Propagation is travel. So the travel of what's light in a straight line. So the rectilinear means you're talking about a straight line. You're talking about the propagation as the travel, and that of the light. So you're saying that the traveling of light in a straight line. That's what it means. I hope I've made myself clear. So we are saying that light travels in a straight line. And just as you already know, we normally, when we talk about rectilinear propagation of light, we normally use the cardboard experiment, whereby 3 cardboards are assembled, and when they are assembled, they are aligned. Before they are aligned, holes are punched in these cardboards at the same point, and when they are punched in them, they are aligned on what do you call it, or they are arranged on a table, so in such a way that a person from one point can be able to see through the 3 holes to another point. I hope I've made myself clear. and a light or a lamp is placed at one side, then observer is at the other side. Now it is an experiment to determine if light indeed travels in a straight line. So it is expected that when a person is standing in front of the three cardboards, the person should be able to see the light that has been lighted after the third cardboard. So the person looks through the three punched holes to be able to see the cardboard. Now, when a person is able to see, the light source, sorry. So when a person is able to see the light source, then it is assumed or it is concluded that light indeed travels in a straight line. Now, the control experiment is that to still show that light travels in a straight line, we may want to distort, what do you call it? We may want to distort the middle cardboard. Now, when the middle cardboard is distorted, when I say distorted, I mean that it is displaced, or when it is slightly tilted, you realize that the light won't be able to pass through the hole because there's a shift, and as a result, the observer won't be able to see the light source, which is after the third cardboard. I hope I've made myself clear. So after this experiment, we then conclude that indeed light travels in a straight line. And you can, examination, they can even tell you that write an experiment to demonstrate that light travels in a straight line. It can be normal inter-science. You can have that, and you should be able to write it using a cardboard experiment. I hope I've made myself clear.
Yes, sir.
So light travels in a straight line, but not in a curved line. It travels in a straight line, not in a curved line. So that is it. Now we are going to talk about rays and beams. Rays and beams. Now when we say rays, we are saying that rays are, or ray is a direction or path taken by light. So a ray is a direction or path taken by light, and it is always normally represented by a line and an arrow. The arrow showing the direction of the ray. That is it. So when if I write this, so this is a ray, and when I write it, this arrow shows the direction of the ray. Are you getting it? So a ray is a direction or path taken by light. Now a collection of rays. That means if I have about 3 rays, we call it a beam. When I have a collection of rays, we call it a beam, not beam nation, please. There's a beam, BEAM. And so a single distance is what we call the ray. A collection of these rays is what we call the beam, BEAM. That is it. Now, so we can therefore now define a beam as a collection of 2 or more rays moving together. A collection of 2 or more rays moving together. Now, these beam can be grouped into 3. We can talk about a parallel beam. You can talk about a convergent beam. You can talk about a divergent beam. And from there, we are going to explain what a parallel beam is. We're going to talk about what a convergent beam is. We are going to talk about what a divergent beam is. The class will end, then you join again, then we finish the class.